Hello students, I am Dr. V. Sudarshan Rao. Today's module is HACCP. HACCP is actually abbreviation for Hazard Analysis Critical Control Points. This concept came into existence because people have realized that end product testing for food safety is not sufficient enough to counter all the hazards. So now the concept is from farm to consumption. So the entire food chain has to be tracked. So this particular concept will apply in that. So for today's module, the learnings that we are going to take from this is HACCP and its principles and its benefits and the application and also the prerequisites for application of this HACCP. So at the end of this module, we are supposed to learn about the concept of HACCP and its advantages, principles and application of HACCP, and also some prerequisites for application of HACCP we should be able to understand. Before going into the HACCP proper, I would like you to understand what is the historical background of HACCP. The National Aeronautics Space Administration of United States of America, they used to spend space missions for various purposes. But the food that has to be provided to the astronauts has to be absolutely safe, and they will have no alternative supplies of food in space. Pillsbury Company, which is actually was supplying food for these astronauts, was first tried to address the issue of food safety. In 1979, the first concept of HACCP was presented in National Conference on Food Protection. So after that, in 1974, HACCP was actually US FDA started applying this for low acid canned foods. In 1980s, HACCP concept gained acceptance in many other food industries, not only in low acid canned foods but also in other food industries. Now people have realized that's a very important concept that will address the food safety. So all international agencies like Codex Alimentarius Commission and other agencies also are actually recommending for the application of HACCP for food safety. In India also, Food Safety and Standards Authority of India also recommends HACCP approach as a part of food safety management program. So there are 7 principles of HACCP. So we'll go one by one. The first principle is the conduct hazard analysis. So what are the hazards? Actually, in food safety, there are 3 typical hazards that we can encounter. One is the physical hazard, the second one is the chemical hazard, and third one is the biological hazards. Physical hazards are nothing but the physical contaminant that can be like a hair or a piece of bone in the food or even a pin in the food, and these are considered to be physical hazards. The next one is the chemical hazards. So these are the like pesticide residues or any antibiotic residues or even hormones that can come through the animals also into food. So these are considered to be chemical hazards. The last one is the biological hazards. The biological hazards can be a microbiological contamination and related to biology. So the first principle is to try to identify these hazards at each step of food processing, assessing and the risk associated with them. So we will be assessing the risk, whether there is any risk with this particular hazard. So when you are actually trying to conduct the hazard analysis, the following things have to be considered. So one is the most important is the likely occurrence of the hazard, whether the particular hazard, what is the likely occurrence of that in the food that we are processing, and severity of their adverse health effects, whether it causes any adverse health effects. And the qualitative is the quantity or the quality of that hazards in terms of saying that what is the amount of that hazard which can actually cause the hazard. And the survival in case of microbiological contamination or even biological hazards, we are also supposed to see the survival and multiplication of microorganisms of concern. That means sometimes in the food processing some of these organisms are killed. So that also has to be considered when you are actually doing the hazard analysis. And the production or persistence of foods of toxins, chemicals or physical agents. That we also see that sometimes some toxins are even produced during processing and how much they are persisting in the food. All those things have to be considered. So in addition to these things, the conditions responsible for the occurrence, survival, multiplication of pathogens or production of toxin, persistence of chemical physicals also has to be considered when you are actually trying to do the hazard analysis. So we take a very simple example of processing a liquid milk. You know very well, in India we are actually number one in the milk production. So we try to see that very simple examples when we actually try to apply the HACCP. So the physical hazards in a liquid milk could be a dirt or animal hair, because while milking this animal hair or even some of the physical contaminants like mud, other things also can come into the milk. These should be considered as a physical hazards for liquid milk. Then what are the types of chemical hazard that we can expect in a liquid milk is the pesticide residues. You know, these pesticide residues can come through the fodder that these animals are consuming, or in the environment if they are very near to an agriculture field, they also can come into milk. The other chemical hazards will be like veterinary drug residues. Like humans, even animals are supposed to be given some injections, antibiotics or even hormones for treating some of the diseases that you get normally in the animals. They also are likely to leave some residues in the milk, so they can also come into your food. So they are present in, if it is done in, even these things are actually, besides these residues, chemical residues, there can be also a bacterial contamination. You know, they are present in milk if milking is done in unhygienic conditions. So as you see that many a time the udders are not cleaned properly, the person who is actually milking may not be, personal hygiene is not very good, so they must have not even cleaned the utensils properly. So all those things also contribute to the biological hazard. So similar, I just gave an example of a milk, liquid milk. This is the very simplest food that I have given an example, but if you want to really check this, you have to apply this concept to other foods also. It is all similar to other things. So then once we do the hazard analysis, then we try to determine the critical control points. That means where actually we now know that there is a hazard. So how do you actually control? Where is the control point for this hazard has to be determined. A critical control point is a step in a process at which control can be applied. That means you can apply the control and reduce the hazard. The control is essential to prevent or even eliminate. Sometimes we can prevent, sometimes we can eliminate, and sometimes we can also reduce the levels to the acceptable levels. In cases like pesticide residues, they should be brought to the acceptable levels. And the critical control point, so how do you identify a critical control point in a food processing unit? So they have actually given one decision tree. So if you try to use this particular decision tree in identifying what is a critical control point for your hazard, you will be able to identify based on this, using by this decision tree diagram. So the first question in this one, you can just see, this will be on the slide, where will be, you can just see that there is a first question is, do preventive measures exist at this step or subsequent steps for the identified hazards? That means we have identified, take for example, I am giving again an example of milk. For a liquid milk, if physical hazard is there, you may actually have put some filter. When you actually, after milking, you are actually passing your milk through the filter. So this filter will take the all physical hazards out of the milk. So that means, do preventive measures exist at this step or subsequent step for the identification? Yes. If it is yes, so does this step eliminate or reduce likely occurrence of hazard to an acceptable level? Yes, because we are talking about a physical hazards. Then that becomes a critical control point. That means you should have a filter after milking that will control all physical hazards in milk. Then we will see the other side. If we are discussing about the chemical contaminants as a hazard, then you just see that, do preventive measures exist at this step or subsequent steps for the identified hazards? Here we are actually talking about pesticide residues. It will not, because filtration will not take out your physical hazards. So is this control step at this step necessary for safety? Yes, because if pesticides are there in milk, you are not supposed to consume that type of milk. So this safety step is essential. Then it is not a critical control point. That means once the milk is there out from the animal, you will not be able to control the pesticide residues. So that means it has to be done even before. That means the fodder or the environment in which the animals are being grazed has to be taken care so that pesticide residues do not come into your product. So that's how now we have seen a physical hazard or a chemical hazard. In both the cases, for physical hazards, we have actually critical control point in terms of filtration. In terms of pesticide residues, you may not have any this thing. It has to be done even before the animal grazing and good animal husbandry practices have to be taken care. Similarly, I will give another example for a biological hazard. Take for example, there is a lot of microbial contamination in your milk. That is a biological hazard. So again, we will be asking the question, is this control step necessary for safety? Yes, that is the reason why in milk processing the pasteurization is actually kept in between. When you pasteurize the milk, it will take care of all the pathogens in the milk. So the the milk that comes after pasteurization will be safe, at least from the pathogen point of view. That means there is a critical control point at the level of pasteurization. So that's how a CCP decision tree, critical control point decision tree, will help you to identify whether you will be able to control a hazard or you cannot able to, and if it is not, what is the best method of doing it. It has to be done before you start the process, or within the process you have a method to control the hazards. So then once you have actually identified that hazards, then you establish a critical limits. These establishment of a critical limit, what do you mean by that? Take for example, I will give again an example of for biological contamination. I will give an example of Salmonella. This is a very dangerous microorganism that can be present in milk. The critical limit for Salmonella is actually 0. That means your milk, for 25 ml of milk, it should be 0. That means the critical limit for Salmonella has to be 0. But we just take another example like pesticide residues in milk. So here, so absolute 0 may not be possible for pesticides. They have actually provided in regulations maximum residue limits. That is supposed to be a relatively safe limit. So in this case, we should be able to control. Supposing example, I will try to give you a DDT 0.1 microgram per gram or per ml is if you assume as the critical limit. So anything more than is not acceptable, anything less than is accepted. So you try to see that whether your milk is actually able to meet that criteria. That is the limit. So these limits can actually vary from food to food. Actually, I am giving an example for milk, but it can be different for different products. So you have to establish this critical limits for your own processing unit or your product. Once we have established the critical limits, then that is not enough. It's limits. Establishing a limit itself will not take care of hazard. So then we have to establish a monitoring system. How do you monitor whether the critical limits are crossed or not, or everything is within the critical limits that we not have to? How do you know that? That has to be by a monitoring system. This is the another principle in the HACCP that we have to take care. So we establish a procedure for corrective action when CCP indicates a deviation from an established critical limits. In the principle 4, it indicates that we should have a mechanism to monitor the critical limits for the food hazards in the food. However, what should be corrective step required if food hazard goes beyond the critical limits? Take for example, if your milk is highly contaminated with Salmonella, what is that you are supposed to be doing? You actually use your pasteurization mechanism in such a way that it is brought to 0, or you have another method of actually controlling that. So what should be done in case if the critical control the limits are crossed? So with the example of pesticide residue, supposing if something goes beyond the DDT limits of 0.1 ppm in your milk, what do you do about it? Do you discard, or you have any other mechanism actually controlling that? If control mechanism is not there, you discard it. How do you discard? You discard and do repasteurization in case of Salmonella, or for pesticide residues probably you may use a system like a dilution effect so that your limits are brought back to. So what is that mechanism that you have put? Has to be actually the corrective action that has to be put in place. So once you have that, you will be automatically making your food safe. That means you know you have identified hazards, you have put the limits, and you also put the monitoring mechanism when your product is going beyond the critical limits. In such case, what is the corrective action? Do you discard or do you make it safe by doing any other mechanism within the process? So, that is the establishing a procedure for a corrective action when your CCP is not going as per your limits. Then once you have set up everything like this, then establish whether once you have done that, you have established a procedure for a correction, all that is done, then you just verify whether entire system is working. That means finally, once you have come from the first principle to the final principle, now we are only trying to see that, okay, we have done all that, we have identified the hazards, we have put these critical limits, we have put the monitoring mechanism in place, and then we also have a mechanism to do what is the corrective action in case critical control point is actually beyond going the control. Then once you have done that, you also have to see whether entire system is working. That means verification of the entire process. If whatever we have done is actually producing the safe food, then that means that your HACCP plan is actually very effective. So you have to establish procedures for verification to confirm the effectiveness of HACCP plan. This is actually sixth principle in HACCP. Once you do that, you are 100% sure that your HACCP plan is very effectively functioning. So once everything is done, now we know that we have done all the, we have followed every principle and we have done that our HACCP plan is perfectly working. Then how do I know that this particular plan is working and what are the mechanisms, what is the actions we have taken? We should have a documentation. So you have to establish, the last principle in HACCP principle says that establish a documentation concerning all procedures and records appropriate to these principles and their application. So you have to actually document everything in your, then you are 100% sure. This will actually give a confidence not only to you, even to the people who are actually dependent on your certification. So then next logical sequence for your this one is that we have to follow. Now we have understood there are 7 principles which has to be applied. How do you do that? Supposing I ask you to do the HACCP application in your unit, how do you do it? We should have some logic sequence. So there is a logic, what has to be done first, that is called logic sequence. So the first thing in your logic sequence is the assemble HACCP team. Again we come back to a very simple example of liquid milk. You should have a microbiologist. You may also have to have a chemist who can actually understand what is a pesticide residues. You may also have a veterinarian who actually is giving injections to your animals. So all these people, and also maybe engineer who is actually looking after your pasteurization unit, and also a person who, if contamination is coming from in your establishment, who can actually look into this. Like that, a team has to be assembled. So this team will vary from product to product. So that means the first thing that you are supposed to do is you see that whether you have that team. It is not necessary that entire team is present in your own unit. It can be, you can actually take an expert from outside also. The ultimate objective is to see that you have all the people who can actually address all the issues with the HACCPs. Then once you assemble a HACCP team, then you describe the product. What is the description of the product? Is that what is the pH of the product, how it looks like, and what is the texture of this one, what are all the physical and chemical characteristics of this product has to be actually described. You know, this will actually try to give a HACCP team that what is the type of hazards you can expect while storage or even processing everywhere. Then the next point of this one comes is, once you describe the product in all the this thing in detail, the next course of action you are supposed to do is identify the intended use. Here in the intended use can be different for a different product. Again, I will give you another milk product as an example. Liquid milk, if you are actually selling for a direct consumer, you are actually giving it to the direct consumption, your identified intended use is different. Supposing you are making a KOA, that means a desiccated milk product from liquid milk, and this KOA will be not directly go to consumption as a food product, it may go as a raw material for making so many sweets. As you know that 7% of milk is converted into KOA, that is actually used to prepare many of the sweets in India. So the intended use for COA is different, for your liquid milk is different. So depending upon that, you are also supposed to be actually doing the HACCP. So if COA has to be dispatched from your processing unit, what are the types of precautions you are supposed to be taking, what is the package, how to transport, what is the temperatures, all that thing will come in. That's the reason why we say that you have to identify the intended use. Then we also have to have a constructive process flow diagram. That means you have to understand how your raw material is coming to your unit and how it is being actually going through entire system, and how finally how it is actually coming out of your product. So this entire sequence of events, if you are actually putting in a order, that is called process flow diagram. This has to be done within the lab or within the unit, and then once you have that entire thing is done properly, then you check whether what you have drawn in your drawing table is okay with the actual. You have to visit each unit of your processing unit. You have to go to your raw material sourcing, how it is coming, who is bringing it, in what form it is coming, and then how it is being processed, how it is being cleaned, or whatever the process you want to do, and then try to see how much time. Actually, this also should take into consideration what is the time taking for. So take for example, again with the liquid milk, you can't store a milk at room temperature maybe for 4 hours. So you have to see that how much time it is actually in the cold chain, how much time it is in the outside. So all that also has to be taken care when you are actually on-site verification, because when we are talking, we may say that it takes hardly 5 minutes, but in reality, it may be taking half an hour, 1 hour. That has to be verified when you actually see the process. Then list all the identify hazards each step. Each step for raw material, you may have a different hazard. I gave an example of physical hazards, and then for a semi-processing unit, you may have some biological hazards or some. So like that, you have to consider all the hazards at each step of your processing and all preventive measures to control your hazards. Okay. So once you have all that, you are actually having a logic sequence of application. Once you are through this logic sequence, you are actually ready to go for the application. Yeah, mere having a logic sequence itself will not actually, you will not be able to directly apply in your unit. There are certain things which are required before the application of HACCP. That means HACCP is not a standalone program. So the factors which actually influence your application of HACCP will be the construction and layout and facilities of your premises, the supplies of water, and what is the type of water that is available for you, what is the equipment and utensils, whether they are actually can contribute to some contamination in your food. So what is the type of equipment you have? Mostly we expect it to be stainless steel. And what is supplier control and management of materials? That means whether your raw material is actually maintaining the same standards every day, whether your supplier, you have any control on the supplier systems of your raw material. So if that is not there, your HACCP application will go haywire. Then do you have any waste disposal? Because if you are not having a proper waste disposal, that itself actually will contribute to the contamination in your food. So you should have a very perfect waste disposal system. So what is the cleaning and sanitation? How frequently you clean? Whether your cleaning and sanitization processes are actually effectively working, and do you have any mechanism to that? So how do you have a pest control? Many of the food industries, the pest control is a major issue. You have a lot of cockroaches, or sometimes you may have even animals like cats, even dogs sometimes. So how are actually, or even the insects, how are you actually controlling that? Whether you have in your system, whether you have control on your this type of pests. So whether you have that in your place. And what is the most important thing in the prerequisites is the personal hygiene. How actually people in your the unit, how they are, what is their personal hygiene, whether they are actually having any bad behaviors like pawn chewing habit, or you are actually having whether they are combing their hair properly, whether they wash their hands properly, whether their attire is good. All that also influence the food safety. That what is the personal, these are very important input food handlers. Then you also have to look up whether you have, supposing you have made a very good product, but your transport and facilities, you are dependent on somebody, and that is actually is not maintained. Whether if supposing your product has to be cold chain, that means it has to be transported in 4 degrees. Whether your transportation vehicle has that facility, whether it has any cover to that during the transportation, whether there is any likely to be any problem. So all that has to be there. And then once you send this product into the market or to your consumer, is there any way to trace? Can you trace your product? That's very important. You should be able to trace your product, so that if any time you find that there is a problem with your product, you should be able to identify, yes, this is the batch on that particular day that we have prepared. We should be able to collect it back from the market. So that means there should be a mechanism to have this traceability. Once you trace your products, if something is going wrong with your product, you should be able to recall. Can you just have a mechanism? Okay, I can just recall my products. Very specifically, this particular batch I can recall from my the consumers or whoever it is. You should be able to. This is not only trying to tell that you will recall. What is the mechanism that you will use to get back your? So whether you have put that process in place in your system. Then the training is the people who are actually at different levels. You should be able to have a training. For food safety, we always say that commitment of the management has to be 100%. Then at different levels, supervisors, then food handlers, there should be a regular training, and they should be trained regularly. Not only regularly, refresh courses also have to be given, so that they will be always attentive, because food safety is a 365 into 24 into 7. That means you just cannot relax in terms of food safety. Anything can go anytime wrong. That's why the people have to be very alert. For them to be very alert, the regular training has to be conducted to your food handlers. Yeah, now we see we have discussed a lot about HACCP and its application. So what is it actually the benefits to the industry or company? In conventional end product testing, there is a risk of losing the entire batch. So if it fails, so those things are actually taken care. So a lot of reduction in your waste, a lot of reduction in company time, all that long-term benefits also will be there for a company, like reduction in wastages, increased consumer confidence in products, and consequently you will have a better market access. So what are the benefits to the consumers? If you actually see the HACCP certified products in the market, you know that you are actually having a lot of confidence that product, that it will not cause any health hazard. So that means there is consumer confidence will increase on your product, or even to the consumers also, they will have less risk from the product. Then benefits to the also to the government. If the industry uses, consumer uses HACCP, the benefits also there for the government. So benefits to the government will be to help more than one way, that it helps efficient food control and also reducing healthcare costs in terms of foodborne illnesses, and also assured safe supplies to facilitate even international trade. To sum up the module that we have learned is that now we understood that HACCP is a very important concept in ensuring food safety, especially biological hazards. Now it is being used even for other hazards also. Then there are 7 principles that have to be actually understood if you really want to apply HACCP. But the application of that, there is a logic sequence in the sense that what are all things that have to be taken care before you want to apply HACCP. So there are some 5 steps that have to be taken care in the logic sequence. And finally, the HACCP itself is not a standalone program. That means it needs a lot of requirements before it can be applied. So today we have learned what are the prerequisites, even the construction, the type of manpower that is required, the personal hygiene of the manpower, then water resources, all that is actually part of the prerequisites that is essential if somebody wants to apply HACCP in their food unit.